Hi everyone, this is Emily and we're doing 16.7 surface integrals. We're evaluating the surface integral for the given vector field F and the oriented surface S. In other words, find the flux of F across S. For closed surfaces, use the positive outward direction. So I picked one that we would have to convert to spherical coordinates, and our row wouldn't just be 1 this time. We have to put in 2, and that it's oriented downward, so we have to do an extra step. So let's get started. So real quick, normally I start all of these when it says hemisphere, we have to know the equation, and so we would choose a surface parameterization. Since it's a hemisphere, it's half a sphere and it's the upper half. So, and we would know that the bounds, since the upper half would go from 0 to 2 pi, no restrictions, but since it's the upper half, this is the range for phi. So that's good to get that started because it's obviously going to affect your answer. Anyways, so rho equals 2 because of that. And we can now convert these to spherical coordinates. So we have x equals 2 sine phi cosine theta. It's a horrible looking theta, sorry. 2 sine phi sine theta, and then we have z, which is 2 cosine phi. So now we can do our partial derivatives, which is always a step because we need to make a normal vector, and so you need to do cross product. So this is what needs to be in the formula at the end of in the integral, but it's just so we know what's going on. So now we need to find I guess we'll do phi first, just to stay in order. So now we can take our partial derivatives with respect to phi. So we're looking here, the derivative of phi, partial derivative with respect to phi is 2 cosine phi cosine theta. And we just keep going down the line. Oops, I wanted to write this a little differently. I wanted to write it going across. So now we're looking at the y component. So we have 2 cosine phi sine theta, and be 2 sine phi. Let me just erase this real quick because it's making everything really ugly. So then we have the r of theta, so we do partial with respect to theta, so leave front alone. This is negative sine theta, and then we have 2 sine phi cosine theta. Then we have to negative, oh, sorry, that's not a theta. So this would be 0. Sorry about that. So now we are ready to find our normal vector. So we can just write this out. I'm going to zoom in a little bit. But maybe it's easier for you if you can see everything. So I'll keep it wide. So we'll just start writing all of our information in. And hopefully I can write smaller. Oh gosh. Yeah, maybe we make a smaller little, just so it fits a little bit better. This is why I wanted to zoom in. Okay. Just because it gets a little crammed. Okay. Just to keep it nice and neat. So we have okay, so we can double check this really quick if it's time permitting. Looks pretty good. A lot of negative signs to account for. So now we can just start doing the cross. So we have this going that way. Well, that's great. So that's just 0 minus so we're going to have a square in there, so we know we need to remember some of our trig identities here. Negative sign for the j, and we're going this way to the 0, so that's great. And then going all the way this way, so another 2 negatives, which will make it positive, but we need to keep this sign here, else we're going to go crazy trying to think about this later on. That is a lot of signs. Okay, and we should remember to keep track of the i's and the j's just in case. Not too big of an issue here. So now we're doing k, so we're going this way, then that way. So we have 2 cosine phi, cosine theta, times, sorry, minus 2 cosine times so 2. Okay, so this looks crazy. So definitely out of space. So let's just put this all together. And then we have an important next step after this. After we put all this together, we need to stop and orient this correctly. It has to be oriented downward. And so when the orientation should be downward, that means that the z has to be negative. And so if it's not negative, then you have to multiply the entire thing by a negative sign. So just go through this. We're just looking at this will kind of just become positive sine. We knew that was the case. Cosine theta. I'm going to keep my components for now. So this is a negative sign, this is a negative sign. So this will be positive. So we'll have 4, another sine squared, phi sine theta, and this is positive, there are no negative signs, so that's easy. So we have we have a lot going on. 4 sine, I'm trying to do something in my head, but I'm not quick enough. I know this is, so we're seeing like something could cancel here potentially with something else. So let's think, can we pull something here out? We should be able to. We should be able to pull, it has to be a theta though. I'm not sure what it is. The music got really weird as well. So let me find another piece of paper. And so, like I said before, these are our bounds that we had. And this is kind of the overall formula. We need to put this here because it's oriented downward. And so we just did our cross to get our normal vector. And so we just now plug in. So we've already found the spherical coordinates for this. We also took the partial derivatives and did the cross product for this. So now we just plug in. So this will give us 2 sine phi sine theta You have to have really small handwriting for all these trigs. It's kind of impossible. See, that's just like the F, and that's sad. And then we have, you know, this part here. So let me zoom in. I tend to write smaller when everything's zoomed in. Let me change colors a little bit. So putting that negative sign there for the fact that we need to flip things around. And now we can put our, oops, doesn't need to be there, our normal vector we found here. Great. So let's zoom out so you can see what's happening. So this is our F. This is that cross. And so now it's just trying to multiply all this together in a correct way. And so we have to zoom in again. So we're putting or inserting this here, this one here, and so on and so forth. And so we have -8 sine cubed plus that. Don't forget your d phi, d theta. It's just hard to write it all on this thing. Sorry. So now some things can start canceling and moving around. So we can so we can take a sine squared out. And that way we can add these. And so these cancel out. I don't know why this is so hard for me to see, but these go bye-bye. It's pretty clear. So now this is like a manageable problem, thankfully. And we can do u sub here for the phi, and u cosine, just real quick, negative sign. So now we don't have to worry about that negative sign, and we have cosine 3 over 3. And so this will give us, I'm going to ignore the 16. Cosine of pi over 2 is 0. Cosine of 0 is just 1. So we're just looking at negative 16 over 3 times 2 pi, which is negative 32 pi over 3. So this is our answer. Okay, thanks for watching.